So we're going to go ahead and take these bolts off, the high voltage and the mounting bolt. But before we do that, let's go ahead and take this harness connector off right here. You just want to be gentle. You don't want to apply too much pressure. You want to take this white clip off. Okay, let's get that out of the way. That's the main one for the temperatures. Let's get that out of the way. And then we're going to take it right here. And that goes up. Let's go ahead and remove it. Alright, you got your 6 bolts for the mounting off. The 4 bolts for the high voltage. Now obviously with this system, and make sure it's in off position. Make sure it's not on, it's in off position. You definitely want to make sure. You do not want to make that mistake of it being on. You have to be patient, take your time. Sometimes the bolts are a little stuck. Alright, so now we got that off. So this just go ahead and climbs up, upwards, and then towards you. So up, like that. And then towards you. Alright, so now we see these aluminum spacers. Let's go ahead and take these off. Now, actually, let's just leave those on. Those are for the high voltage. Let's go ahead and just leave that on like that. Let's put the bolts back in. So you got 1, 2, 3, 4. These are for the high voltage. Now you definitely want to be wearing gloves while you're doing this. I'm just putting these bolts on very lightly, very lightly. You do not want to apply too much torque. You can strip these bolts very easy. See how I'm going very slowly? Very slowly. Take your time. There's no rush. Alright, let's go ahead and get the tools out of the way. And let's go ahead and get the back side done. So, that's the front side where the high voltage parts are, connectors. So the back side is this foam cover, and you got 5 clips. So let's go ahead and take these off. We just need a flathead. Take the clips off. Sometimes they can be a little strong, so go ahead and put them on. So I'm going to go ahead and flip the battery. So I'm just getting it out of the way for the camera. Alright. Let's go ahead and take all the clips off. Make sure you take your time. Foam clips are pretty strong, so make sure you take this aside. It has a danger warning, so you definitely do not want to keep metal. This has power, so you do not want to touch these across. There's a lot of safety involved. Like these tools should all be covered with electrical tape, and you do not want to keep tools near the terminals. These are all the terminals, and you definitely do not want to keep those with metal. Alright, let's go ahead and put that aside. Let's turn the battery, and let's get the analyzer going. Alright. lighting. All right. All right. Just so you can see everything, folks. Okay, so let's go ahead and connect the analyzer to the battery. So what's included is this extra cable. Looks like this. And you're just going to go ahead and connect these banana plugs to the bottom, like so. All right. And let's get out our voltmeter so we can check for polarity. Okay. So what we're going to do is check for polarity on the battery. Okay. So we're going to start at this bottom one right here. We'll just start at the top one, just keep it simple. Right here, right where my finger is. You want to leave. I'm just moving the battery so you can see it, but normally you wouldn't want to move the battery. So I'm taking it like this, holding it on one stick, and on the other side, you want to check it too. And it should come up as 7 volts. 7 to 8 volts on average. Now, if you have from the same side, just on the opposite side, so 7.85. So that means we're touching one stick or one module. Now, if it was 15 volts, then that means we have been touching 2 modules. And we've only been touching 1. You want to make sure it's the right one. So there's 20 modules, 20 of these cell modules. You want to make sure you're touching the correct one. So now we got the correct polarity. So negative is on my left hand, positive is on my right hand. Now this is a very easy connection, not complicated. All right, so let's just go ahead and connect this. You got positive, negative. Very easy. So we're going to go ahead and connect it directly, if you can see this, the negative to the negative terminal. Now it's a little tight, so go ahead and force it on a little bit if you have to. Okay, like so. Let's get this out of the way. And the same thing on this side. Alright, it's on. We're going to double check that the clamps aren't loose. They're nice and tight. Alright, so now that the analyzer is on, we're going to take our stylus. We're going to start at the beginning. Alright, so we're going to start. Let me zoom in so you guys can see this. Alright. Start where it says user settings, and then cutoff capacity. Now it says 5.6 amp hours. We want to change that to 6.4. If you can see that, it says 6.4. So it's a 6.5 amp hour cell. 6.4 is close enough. That's about as you really don't want 6.5. 6.4 is actually better. It's less heat. So say okay. And you go back. So the first step is to drain this. So what we're going to do is go to type, go to nickel. This is a nickel battery. And it's at the discharging settings. And then we're going to click on cells. And then it's going to drain to 5.0 amps. 5.0 volts. And we're going to check the amperage. The amps is 3 amps. So we're going to go ahead and start the test. Now, as you can clearly see, that the amperage right here labeled in green, we'll start at the top. The red one is the voltage. Now, this is under load. So as the amperage goes higher and higher, the voltage will go less and less. So this amperage will go higher, and then this will go lower. Now, this is normal. So we can tell clearly that this cell is not dropping out because the cell is not at 6 volts. It's at 7.6. So it's probably going to be good. And this is a 1.4 amps discharging. And it's been, right now, maybe about 30 seconds. So it's about 8 milliamp hours. And we can tell right here, it says if you need to stop it, you can just click stop. And then it shows discharging the cells. And then the time, the exact time is down here. It'll say 1 minute exactly, 1 minute and 12 seconds. And the one thing you don't need to look at is on this right side where it says 31 degrees Celsius. That is not important. You don't need to know that. That is only for advanced testing. We're doing basic rebuilding, so you don't need to remember that at all. So this is going to go all the way down to about 5 volts, and it should be roughly, let's say, I'm just estimating, 3 amp hours on average, because the battery is not fully charged. It's only going to be halfway charged. So typically, it's going to take at least a couple of hours to have this drain out. Now, I'm not going to let this record for a couple of hours, but I'm going to play it back when this gets done. So we're going to let this drain out, and then I'm going to stop the camera and then play it back once this is done. Just show the first step. All right, so imagine it drained. We're just going to fast forward this. So we're going to go to the next part, which is charging it. So that's the first part. The first part is always discharging, always drain it first. So the capacity is still the same, 6.4. All right. Now what we want to do is click on PB. And the reason why we're clicking on PB right here is because this is a nickel battery. It doesn't matter if we're switching it to lead because it's going to still put 2.5 amps in there. So it doesn't really matter. And the reason why we switched it to lead, PB, instead of nickel is because this analyzer will normally shut off at around 80% charge. That's how nickel is designed. So you want to bypass that by switching to PB. Otherwise, we would not be fully charging this. So we want to switch it to PB, and it will go ahead and start the charge. So let's let this load up. Give it a second to load. All right, so charger is loading. Now, as you can see, this is the amperage. The amperage is going up. It's going to, right now it's at 0.5 amp. And as you can clearly see, the voltage is going up. As you add amps for charging, the voltage will go up. So it's the opposite of discharging. In discharging, the voltage will go down as the amperage goes up. But as we charge it, when the amperage goes up, the voltage goes up. So right now, we've been letting it sit for about 50 seconds, 52, and we have put in about 7 milliamp hours. Now this charger will stop at approximately 6.4 amp hours. That is an exact 100% fully charged battery. Now that takes, at 2.5 amp hours, that should take roughly a little over 2-3 hours. So we're not going to let it sit that long, but this is just the example of it. So that's what you're going to do. So we're going to stop the charge right now in a second. We're just going to pretend that it went to 6.5. So we're going to stop it. So once it goes to 6.5, this is the important part. So we drained it. That we just charged it. Now we're going to drain it again. Now, this time when we're draining it, this is an important analyzing test. And it's very important that you actually look at the numbers correctly, because these are the numbers that we're going to be going to write down to see the exact health of this cell. And the cells should be over 4.0 amp hours. So let's give this a second to warm up. Now, obviously, I haven't fully charged this, but if I did, it would show 4,000 milliamp hours. That would be 4 amp hours. So it's a very simple number, not complicated. That would be the bare minimum. So anything above 4,000 is good. Anything below 4,000 is considered to be bad, or you might have to test it again to make sure. So it's pretty simple. And on the second discharge, I'll write this down. On the second discharge, this is the most important step. Anything above this number is 4,000, considered good. Anything less than 4,000 is bad, and you have to test it again, or you can discard it. But I recommend testing it 2 or 3 times in order to get the capacity up. So this is a very basic rebuilding. It's not complicated. It's just a few simple steps. And then once you drain it, let's just say it's at 4,000, right? So it's at 4,000 and then it stops. It's going to take a couple of hours to drain. And then we're going to go ahead and then switch through all 20 of them. So we just did for the cell number 1. So what you want to do is switch through all 20 of them. So that's pretty much it. It's not complicated. And it's a very simple step. You're just repeating it. So you drain, charge, then drain. So 3 easy steps. Drain, charge, then drain. And then you just go through all 20 of them doing the exact same thing. And then you just want to write the numbers down. So we got this out here. So we're going to write down number 1. So as an example, if this had 4,000, let me zoom in. If you can see it right here, this orange part, 4,000 milliamp hour is 4 amp hours. That's reasonable. That's pretty reasonable. So let's just say it had that. We are going to go ahead and write down its capacity. So number 1 is 4.0 amp hour. Or you can write 4,000 milliamp hour. Same thing. No difference. There's just a difference of how you point the decimal. The same exact thing though. Alright. Now a good one that's perfect is above 4.0 amp hours. So on the next one, if, for example, it's 2.6 amp hours, that's obviously low. So this number is less than perfect. This is the bare minimum. I wouldn't call it perfect, it's the bare minimum. Anything below 4 amp hours, you have to check it twice. If it's above 4 amp hours, then you can move on to the next one. Alright, so it's a pretty simple rebuilding. There's not a whole lot of mistakes you can make. You're not disassembling this battery, so you're just exposing the terminals on each side. And then that's basically it. There's not a whole lot of things to make mistakes. Now keep in mind this is one analyzer to go through all 20 sticks or all 20 of the modules, and it should take anywhere from 5 days to a week depending on how often you do this. Now normally you should be doing this 24 hours of the day, and you do want a fan, any small kind of fan to blow up against this will work. And you want to get some good circulation. You don't want objects to clutter this. This is an airport, like an air vent, so you don't want any objects going close to this, such as the wall, because you need good air circulation to go through this. And then you don't want any water nearby this or tools, such as a regular tool. Again, this is safety. You don't want tools around here. You want to keep the area nice and clear of any obstacles or any debris, anything at all. You want to keep this very nice and safe. I recommend wearing gloves this entire time. Wear rubber gloves just to be super careful. You do not want to make any mistakes. You don't have to, but I highly recommend it. So this is step one in the general rebuilding. So we want to write down right here all 20, and then write down their capacities so you don't forget, or you don't mix them up. And you don't want to mix them up on the battery because there's clearly 20 of these and you can easily mix them up. So you definitely want to look at it right, and you can always put to number the cells, you can always stick like a marker on the side of terminals if you like. I use markers, or you can do this. This is what I do sometimes. So let's look at this. So this is one that I had previously tested, and I'll show you right here. This is a 5.7 amp hours, but the reason why I put CD is for self-discharge. So that means that's for advanced testing, self-discharging. So over 4 days. So that means it held that capacity over 4 days. So that's an advanced test. What we just did is a general test. So don't mix them. This is to get your car back on the road. If you're still having problems, then you want to go to the advanced test, or you can do them later. It's really up to you. There's no right or wrong answer. And this is a very good demonstration to show everything about the analyzer and the battery, how to rebuild everything. You want to make sure you're not making any mistakes. You want to go through all the terminals, make sure there's no damage or corrosion. And don't take it, again, do not take this battery apart. How you see it is how it should be. You do not want, let me get this out of the way. You do not want to touch, you see this orange part right here? You see where all the bolts are? You do not want to take off all 20 bolts. And then I don't know if you can see, but right here, there's 20 little mini bolts, I call them. And there's 20 of the big ones, and then 20 of the small ones on each side. So this analyzer is isolated. So if you purchase 2 analyzers, you still don't have to take this off because it's isolated and there's no issues of high voltage dealing with this analyzer. So everything is laid out to where you can rebuild this battery with relative ease. So you don't have any problems. And this is a very good setup. And I'm going to show you again what these cells look like. So these are pretty good, just to keep this in mind. This is what the cells look like. Technically speaking, these are the cells, right where my fingers are. So you got 1, 2, 3, 4, 5, and 6. So there's 6 cells per stick. And then this right here is the negative terminal. And on the other side is the square is the positive terminal. So it's very easy to remember those. See? Very simple. It's not a complicated rebuild. And after this, you should be fine just installing it back in the vehicle. We have other videos coming out pretty soon that will show you more information about advanced tests, and then how to install it back in the vehicle. And then there's going to be the last video is for troubleshooting. If you're still having problems and you still can't make the car with the check engine light to be removed, uh, there's going to be troubleshooting, such as if you made a mistake somewhere. We'll go ahead and answer those type of questions. So that's it for today, folks. All right, have a good one. Bye.